We'll do two examples here from the Motional EMF lessons. The first one is of the airplane flying to Mexico. So figure out what the EMF that develops across the airplane's wings is. And the second one is that of a falling rod in Earth's gravitational field. Actually, both are in Earth's gravitational field. So the example one is at the top here. Very short, very quick, just plug and chug. But let me explain my sketch here. So we're told to assume a vertical magnetic field for the Earth here, and it's half a Gauss or 0.5 times 10 to the minus 4 Tesla. So it's pointing vertically up from the ground. This is not really the case most places on Earth anyway, but let's just assume this. This is the wingspan of the airplane, and the airplane is coming at us. So this is really my schematic of the airplane's wings, and the velocity of the airplane is 275 meters per second. It's coming at us, which is why the velocity vector has this symbol. It's pointing at us. So the question here is, what is the EMF from one end of the wings to the other at this constant velocity? So VAB is what? And we'll just apply the formula that we know. VAB is going to be the strength of the magnetic field times the velocity times the length of the wingspan. So then when we put in all the numbers, we're going to have, so 0.5 times 10 to the minus 4 Tesla times the velocity being 275 meters per second times the length being 34.10 meters. This is the length given in that figure of the airplane in the problem. So then this will add up to be 0.47 volts. So this is the EMF that develops across one end of the wing, one end of the wings to the other. So that's example one. Let's go example two, where we now have a rod, conducting rod, free falling in Earth's gravitational field, from an initial height of h of 6 meters. The width of the rod is 6 centimeters. And we're told that the rod is oriented east-west, and the magnetic field of the Earth is pointing north. It's actually going to be into the board now, and it's again half a Gauss. So the question now is, so we know again an EMF is going to develop across this rod, but because now the rod is accelerating in Earth's gravitational field, it's not moving at a constant velocity. We now know that the magnitude of this EMF is going to change as the velocity increases. So then the question is, what is the rate at which the EMF across the rod, VAB, increases? So what is the derivative of VAB with time? So let's figure this one out. Again, we'll use our equation for the motional EMF. This is going to be B V times L. L is 6 centimeters, B is Earth's magnetic field, V is that velocity that is changing. Now, so the velocity is starting from 0 at 6 meters, and then is going to start increasing as the object falls. So then our expression for the velocity as a function of time under constant acceleration is going to be the gravitational acceleration, g times t, as time goes. So then we will put, so this is velocity here, not potential. So we'll put this in here, so then our expression for the potential becomes b g t l. So now we see that the potential there is with time t. Now the question that we had is, what is d, the change in potential as with time? So all we have to do is differentiate this with respect to t. So then we get that this is going to be b g l, and that's it.